Hello, boys and girls. How's it going? We are in Chapter 4, Lesson 10, and the name of this lesson is Place the First Digit. So when you're doing long division, you have to think about where the first digit of the quotient goes. For example, on number 5, does the first digit of the quotient go above the hundreds, above the tens, or above the ones? Okay, so when they're talking about placing the first digit, they mean where does the first digit of the quotient go? All right, so I'm not like a super big fan of math tricks. I like you always to know exactly why you do things. But we talked about why long division works when we did the lesson with the base 10 blocks. Okay, and we separated the base 10 blocks by place value. So I'm going to write, does McDonald's serve cheeseburgers down the side here? Okay, now D is for division, M is for multiplication, S is for subtract, C is for check, and B is for bring down. So it's, does McDonald's serve cheeseburgers? Okay, it's just a helpful way, if you need it, to remember what you do when you do some long division. And I bet your parents know how to do this too if you need extra help, okay? So when you think about placing the first digit though, you're thinking, okay, place value by place value. I have 7 hundreds. Can I share 7 hundreds in 2 groups? Absolutely. That's how we know where to place the first digit. If that was only one set of 100, the first digit couldn't go there because we can't share one set of 100 with 2 people. We can't give 2 people each 100, right? But we can share 700 for sure because it's only 2 people, so they'll each get a few sets of 100, right? Okay, so here we go. D for divide. Now, this is 7 hundredths, but we're just going to look at it as 7 when we do the division. And you think, okay, how many sets of 2 can I get into 7? How many 2's are in 7? 2, 4, 6. I just lifted up one finger each time I said a multiple of 2. So I went 2, 4, 6. 3 fingers. Okay? So 2 can go into 7. You'll hear that a lot. How many times does 2 go into 7? It goes in 3 times. So I'm going to put the 3 right there, placing the first digit above the hundreds place. Be really careful about where you place the digits. Okay? It's going to help you when you start doing longer division problems, and now as well. Okay, so we did the divide. Now we're going to multiply. So if 2 can go into 7 3 times, how many sets of 100 is that? Here's the multiply. 3, let me change colors here. 3 sets of 2, or 2 sets of 3. What's 3 times 2? That's the division. 3 times 2 is 6. So we're going to put the 6 there. And now we're on the S for subtract. We have divided 6 sets of 100 away, so we're going to subtract it. 7 minus 6 is 1, so we have 1 set of 100 left. Now we're on the C for check. Don't skip that one, okay? Check means you're going to look at that 100 that you have left. Make sure that number after you subtract is less than the divisor, the 2. Because if it's more than a 2, then you could have given away more of your sets of 100. So the C for check, you go subtract. Okay, 7 minus 6 is 1. Check the 1. Is the 1 less than the divisor? It is. Okay, so then there's B for bring down, meaning you are now going to start working with the tens place too. I'm going to bring down the 6 from the tens place. Okay, so now I have 16 tens. If you think about those base 10 blocks, it's like I broke apart the one set of 100, and now I have 6 sets of 10 also. So I have 16 tens. We're going to start back up, bring down, whoop, go back up to divide now. And your teacher might have a different way to memorize these steps, but this is just the way that I always use. Okay, so D for divide. How many sets of 2 are in 16? How many 2's are in 16? I'm going to count by 2's, and every time I say a multiple of 2, I'll put up a finger. 2, 4, 6, 8, 10, 12, 14, 16. There are 8 sets of 2 in 16. So that's the division part. Okay, 16 divided by 2. So now I have the division done, and I have to put the division up here because that's part of the quotient. Remember, you're doing a division problem. So when you're on that D for division, make sure you don't go, oh yeah, 2 goes into 16 8 times. Big deal, I don't care, I'm not going to write it down. You have to write it down because we're doing division. You have to write it as part of the quotient. Now we're on multiply. We have 8 sets of 2. 8 times 2, what did we just divide out? 16. Okay? 16 minus 16 is 0. So you think, wow, I remember when I get to 0, when I did repeated subtraction, that means I'm finished. Yay! Oh, not yet. Because look up here in the quotient. We have a digit over the hundreds. We have a digit over the tens. But what about that little precious ones place? We have to deal with that. So we bring down the 6 from the ones place. Okay? Boop. So now we have 6 ones, which we are separating into the 2 groups. And look what we do. Oh, I almost forgot. Oh, no, I didn't. No, we're good. So look, bring down, whoop, back up to division now. Okay? So divide 2 into 6. Of course, you know that one, don't you, boys and girls? 3. So now so our quotient goes out all the way to the ones place, okay? The quotient has to finish at the end of the number. The quotient has to go to the ones place. You have to, in other words, you have to divide the ones place, okay? So now we'll do multiplication. 3 times 2 is 6. Subtract 6 minus 6 is 0. So our quotient is 383. 766 divided by 2 is 383. All right? Let's try number 6 now. So it's 604 divided by 4. I want you to think about placing the first digit. I have 6 hundreds. Can I give 100 to each of 4 people if I have 6 hundreds? Absolutely. I've got plenty. So the first digit is going to go right there over the hundreds place. Okay? Let's go back over here. Ding, ding, ding. D for divide. Can 4 go into 6? Well, you might think to yourself, no. 4 times 1 is 4. 4 times 2 is 8. No. It doesn't have to be compatible. They just want to know if you have 6 hundreds, can you give 100 to 4 people? Sure you can. Each person will get 1. Okay, so can 4 go into 6? Sure, 1 time. So that's the D division. Now we go to the multiplication. And How much is one set of 4? Well, one set of 4 is 4. Then we go to subtract. Subtract that 4 because we gave those out. We divided them away. Okay? 6 minus 4 is 2. Now we're on C for check. Is 2 less than our divisor? Yes, it is. Now remember, if it's not less, that means that we could be giving more of those hundreds away. That maybe you have to think about that first step, that division again. Okay? So we checked it, and 2 is less than 4. Now we bring down the next place value. And look at that, the next place value happens to be a 0. Boop. Okay, guess what? Back up to the D for division again. Okay, you see it's a little cycle, right? Does McDonald's serve cheeseburgers over and over and over again? So can I divide 4 into 20? Absolutely. How many sets of 4 are in 20? Now, if you can't think of that, boys and girls, don't forget, you can write your multiples over there. If you forget, don't just sit there stuck. There's always a way you can figure it out. Okay? So look, 1, 2, 3, 4, 5. 4 can go into 20 5 times. And I'm carefully writing that part of the quotient over the tens place, over the place that I just brought down to divide. All right? So that's an important part. Don't forget to write the quotient up there. So I did division. Now I'm going to multiply. So let's see. 5 sets of 4 is 20. 5 times 4 is 20. Go to subtract, right? Minus 20 is 0. Is it time to celebrate yet, boys and girls? No, 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 not yet. Because of our friend, the ones place. B for bring down. And we're bringing down that 4. Okay? And then we start all over again. Boop. D for divide. Does McDonald's serve cheeseburgers? Divide, multiply, subtract, check, bring down. Right? So, D for divide. 4 into 4. Can 4 go into 4? Sometimes kids get stumped on this one. And they're like, 4? What? 4 times 2 is 8. You know, oh, sure, 4 can go into 4. Just think, if you have 4 circles and 4 ones, everybody gets one, right? 4 goes into 4 one time. Now we multiply. 1 times 4 is 4. Okay? Subtract, S for subtract. 4 minus 4 is 0, and we are finished. So 604 divided by 4 is 151. Okay, let's try some more. So this is problem solving at the bottom of the page, number 13. All right, guys? Let's see what this says. We're going to read and then probably reread because you know how much I love to do that. It helps me so much. All right, number 13. There are 132 projects in the science fair. So 132 projects in the science fair. If 8 projects can fit in a row, how many full rows of projects can be made? How many projects are in the row that is not full? Oh, this is a 2-part problem, huh? So let me go back here. I have 132 projects. So there are 8 projects in each row. How many full rows of projects can be made? So we have 132, right? How many are in a row? 8. 8 are in each row. So I'm taking 132 and I'm separating them into a row of 8, another row of 8, another row of 8, another row of 8. Okay? So we are dividing by 8. And the quotient is going to be how many full rows of projects can be made. The quotient will be the number of rows that have 8 projects in them. But what about this one? How many projects are in the row that is not full? Let's see. I'm going to write the word projects right here. That helps me sometimes because then I remember that every number down in this row, it's projects. So whatever I'm left with at the end, they're still talking about projects. So whatever remainder we might have, that remainder is projects, because this is 132 projects. My remainder is not going to change into rows or some other crazy thing, right? All right, so let's get started here. 8, and now I have to think about placing the first digit. Is it going to go here, here, or here? Okay, so I have to think about 100 flat, right? That we use the base 10 blocks with. Can I give 8 people each 100 if I only have one of them? No, of course not. So I am not going to be able to start my quotient there. My first digit will not go above the hundreds place. I just don't have enough hundreds. So then I'm going to go to the next place value. So I have to break apart my hundreds into tens. So now I have, into tens. So now I have 13 tens. Well, I can give 13 tens to 8 people. How many times can 8 go into 13? Or how many tens are 8 people going to get if I hand them all out? Well, let's think. 8, 16. Oh, 16. That already goes past 13, doesn't it? So 8 goes into 13 just one time. So I placed the first digit over the tens place. Okay, so let me write my little divide, multiply, subtract, check, bring down. Does McDonald's serve cheeseburgers? So I just did step 1, divide. Now I'm going to multiply 1 times 8. So I divided out 8 of those tens. Okay, now I go to the S for subtract. 13 minus 8. How many tens do I have left? I like to count up in these. When I do teens, I go 8 in my head, and then I go 9, 10, 11, 12, 13. Now my fingers, 5. Okay, I subtracted. Now I check. Is 5 less than the divisor 8? Yes, it is. So then I can go to the next step, bring down. Boop, boop. Bring down 2. Okay, so now I'm thinking I have 52, and now we're talking 52 ones, right? How many times can 8 go into 52? Well, if you don't know your 8s like perfecto, you can list them like I always do, right? Like write 8, 16. I'm going to think about, though, 8 times 5, because I love my 5s. 8 times 5 is 40. So let me see, what's 8 times 6 then? 8 times 6, that's another set of 8. 8 times 6 is 48. Oh, that's pretty close to 52. And then so 8 times 7, oh, that's 5, 6, 7, 8. 56 equals 8 times 7. That's too much. So in the division of 52 divided by 8, 8 goes into 52 6 times. Okay, and then we're going to do our multiplication. 6 times 8 is, remember, 48. All right, and you can even count up for this one. Anytime two numbers are close together, like 52 and 48, I count up. I put 48 in my head, and then I count up to 52, and I put up a finger for everyone I count up. 48, 49, 50, 51, 52. 4. Okay? All right, so I'm checking now. I'm on the C for check. 4 is less than 8. B for bring down. There's nothing left to bring down. Okay, so I finished with all the division. But now we have to look back and make sure we're answering what is in the question here. Let me see. Right there. How many full rows of projects? Okay, remember we talked about that? We have 16 full rows. Okay, there are 16 rows that have 8 projects in each row. But then the other part of the question, remember? How many projects are in the row that is not full? Remember up here, I said if that's 132 projects, whatever your remainder is going to be, that's also projects. So you have 4 projects that they're still going to be on display, but they just won't be in a full row of 8. There's just going to be 4 in that row. Okay? So we answered how many full rows, 16 full rows. How many projects are in the row that isn't full? 4. 4 projects are left in that last row. In row 17, there will only be 4 projects. All right, awesome job. Let's keep going. All right, so now, I think this is on the back, yes. Turn your paper over to the lesson check. It says, to divide 572 divided by 4, Stanley estimated to place the first digit of the quotient. In which place is the first digit of the quotient? All right, I'm going to rewrite this over here. 572 divided by 4. Now, Stanley estimated. Okay, so remember how you estimate in division? You look for compatible numbers. Okay, so I'm just looking at that first digit, 5. And I mean, it's not a great estimate, but what's close to 5 that's compatible with 4? Well, what are the multiples of 4? 4, 8, 12. What's the first one? 4, right? 4. Usually I look at the first 2 digits, but 57, that's not a mental math thing, so I'm just going with the hundreds place. Okay? You might know how many sets of 4 are in 57 because you're awesome. But I'm just going to go with estimating to the hundreds place this time. So I have my 5, and I'm going to rewrite it so I have a number that's compatible with dividing by 4. Okay? So what's 400 divided by 4? Well, what's 4 divided by 4? How many? And remember, you can go backwards, like what times 4 is 4, right? You can go this way if you want. So, of course, 1 times 4 is 4. But 1 times 4 isn't 400, is it? 100 times 4 is 400. Okay? So when we look at our choices, if the answer is 100, obviously it's going to be in the hundreds place. All right? Beautiful. That was a good review of estimating too, using compatible numbers in division. All right, let's see. Onetta biked 325 miles in 5 days. Woo! If she biked the same number of miles each day, how far did she bike each day? So she biked 325 miles altogether in 5 days, and she biked the same number of miles. So we have 325, and we're separating them into one day, the next day, the next day. to see how far she rode each day. That is what we call division, right? Taking a big thing and separating it into equal sets. All right. Now say this with me. Ready? Does McDonald's serve cheese burgers? Okay. All right, let's go. Placing the first digit. Does it go here or here or here? Let's see. Can 5 go into 3? If I had 300s, could I give 100 to each person? No, absolutely not. I don't have enough. So the first digit is going to go in the tens place. Can 5 go into 32? It sure can, right? How many times? How many sets of 5 are in 32? Count by 5s. 5, 10, 15, 20, 25, 30. That's 6 sets. Okay? Divide. Now we multiply. If I have 6 sets of 5, how many am I dividing away? 30. Check. Now I'm going to subtract. 32 minus 30, 2. Check. And now I'm going to check off check in a minute. Let's see. Is that 2 after I subtract less than the divisor? Check. Check to check. And then we have the B for bring down. Bringing down the ones place. Okay. 5 into 25. Oh, that's a good one. We love that basic fact, right, guys? 5 goes into 25. Oh, that doesn't show up very well. Whoop. There we go. 5 goes into 25 5 times. So there's our, oh wait, I forgot to check off B and go whoop, back up to divide. You guys probably already did it though, didn't you? So we divided. Now we're on multiply, okay? 5 sets of 5 is 25. Check. And let's subtract and boop. So let's go back to what they're asking us. How far did she bike each day? 65 miles each day. Now I want you to notice choice A. I bet that's the answer you get if you multiply these two numbers. Okay? That's why you really have to think about what's happening in these story problems. Don't just go, well, I like these numbers, I'm going to multiply them. Think about what's really happening. We were separating 325 into 5 separate days. All right, guys, let's keep going. All right, guys, so let's go down to the spiral review. All right, this is number 3, lesson 3.2, which is chapter 3, lesson 2. All right, this is about a guy named Mort. Mort. Cool name. Mort makes beaded necklaces that he sells for $32 each. Okay, $32 is the cost of each necklace. About how much will Mort make if he sells 36 necklaces at the local art fair? All right, so let's think about this. He's got 36 necklaces, and for each one he sells, he's going to get $32. So what operation is this? You have $32 for one necklace, $32 again, $32 again. What is that when we have the same amount over and over and over again? Multiplication, right? All right, so we're going to be doing some multiplying, but I want you to notice this magical word right there, about. I almost just started multiplying those two numbers, but then I thought, oh my goodness, this is an estimate. And you know what really made me notice it? I was looking down here, and I was like, oh my goodness, those all end in 0. What? And then I was like, oh, estimating. Okay? So if we have 32 times 36, we're going to round. 32 rounds to 30 because it's closer to 30 than 40. 36 rounds to 40. Okay? And you guys, I know you're so good at this. Let's just deal with the basic fact. 3 times 4 is 12. Kaboom, 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 kaboom. 1,200. Mort raking in the dough at the local art fair. He's making $1,200 on his necklaces. Way to go, buddy. All right, guys, have a great night. Finish up all your homework your teacher asked you to do. See you soon.